Okay, well, welcome back to our course on software engineering. We're making some good progress, and we have been focusing on this part 3, advanced software engineering. And we're seeing how these are getting a little bit more complicated, but also very more elegant, if you will, in terms of maybe some practical ways of how you're stitching a lot of capability together. And so let's focus on service-oriented software engineering. And things that we'll talk about here is we'll talk about service-oriented architectures. We'll at least introduce some couple of things like something called the RESTful services. We'll talk about service engineering and then service composition. For web services, a web service is an instance of a more general notion of a service. And we can quote as an act of or performance offered by one party to another, although the process may be tied to a physical product. The performance is essentially intangible and does not normally result in ownership of any of the factors of production. The essence of a service, therefore, is the provision of the service is independent of the application using the service. So service providers can develop specialized services and offer these to a range of service users from different organizations. So what's reusable services? Services are reusable components that are independent, no required interfaces, and are loosely coupled. And so a web service would be a loosely coupled reusable software components that encapsulate discrete functionality, which may be distributed and programmatically accessed. A web service is a service that is accessed through standard internet and XML-based protocols. Services are platform and in implementation language independent. So what are the benefits of service-oriented approaches? So services can be offered by any service provider inside or outside of an organization. So organizations can create applications by integrating services from a range of providers. The service providers makes information about the services public so that any authorized user can use a service. Applications can delay the binding of services until they are deployed or until execution. This means that the applications can be reactive and adapt their operation to cope with changes to their executing environment. And benefits of a service-oriented approach, the couple of things we can point out here. You can have opportunistic construction of new services. Service provider may recognize new services that can be created by linking existing service together in innovative ways. That's definitely something that could be value added. Service users can pay for services according to their use rather than their provision. Instead of buying a rarely used component, the application developers can use an external service that will be paid for only when required. Applications can be made smaller, which is particularly important for mobile devices with limited processing and memory capabilities. Computationally intensive processes can be offloaded to external services. What about service scenarios? An in-car information system provides drivers with information on weather, road traffic conditions, local information, etc. This is linked to the car audio system, so the information is delivered as a signal on a specific channel. The car is equipped with a GPS receiver to discover its position, and based on that position, the system accesses a range of information services. Information may be delivered in the driver's specific language. And so here is an illustration of what a service-based in-car information system can have. And so it's an aggregation of sensors, of transmitters, receivers, and all that integrated into the mobile information services that would be readily available in the car. So very interesting, a lot of things that could be easily adapted based on the consumer requirements. So what are the advantages of a service-oriented architecture for this application? It's not necessary to decide when the system is programmed or deployed, what service provider should be used or what specific services should be accessed. As the car moves around, the in-car software uses a service discovery service to find the most appropriate information and service and binds to that. because of the use of translation service, it can move across borders and therefore make local information available to people who don't speak the local language. For software, service-oriented software engineering as a significant development is, this is as significant a development as object-oriented development. Building application is based on services that allows companies and other organizations to cooperate and make use of each other's business functions. Service-based applications may be constructed by linking services from various providers using either a standard programming language or a specialized workflow language. Okay, let's get into service-oriented architectures. This is a means of developing distributed systems where the components are standalone services. Services may execute on different computers from different service providers. And you can have standard protocols that have been developed to support service communications and information exchange. So here's how the service-oriented architecture could look. So you have a service registry, you have a service requester, and then finally you have a service provider. And so these are the things that you would be having, and ultimately you have a published service that you are then can be able to access. So services can be provided locally or outsourced to external providers. Services are language independent, and then there is an investment in legacy systems that can be preserved if needed, and inter-organizational computing is facilitated through simplified information exchange. So what are some of the key standards? Here are three. SOAP, which is a message exchange standard that supports service communication. There's WSDL, the Web Service Definition Language. The standard allows a service interface and it is it's binding to be defined. And plus there's WSBPEL, which is a standard workflow language used to define service composition. So here's just an illustration of the web services and typically where they're used. And so we have the standard transport type of services, HTTP, HTTPS, HMTP. You can have messaging standards, service definitions, you can have process standards, you can have support standards, and all the various XML technologies that can be leveraged. So for service-oriented software engineering, existing approaches to software engineering have to evolve to reflect the service-oriented approach to software development. So there's software engineering and there's software development with services. For service engineering, there's the development of dependable, reusable services and software development that includes reuse. You have software development with services. Gets into the development of dependable software where services are the fundamental components. Software developments, once again, would be including having opportunities for reuse. So what about services as reusable components? A service can be defined as a loosely coupled reusable software component that encapsulates discrete functionality which may be distributed and programmatically accessed. A web service is a service that is accessed using standard internet and XML-based protocols. A critical distinction between a service and a component is defined in CBSE is the service are independent. Services do not have a required interface, and services rely on message-based communications with messages expressed in XML. For a web service description language, the service interface is defined in a service description expression in WSDL, the web service description language. So the WSDL specification defines what operations the service supports in the format of the messages that are sent and received by the service. It also includes how the service is accessed, that is the binding maps the abstract interface into a concrete set of protocols. And finally, where the service is located. This is usually expressed as a Universal Resource Identifier, or URI. Here is just a little bit of information on the organization of the WSDL specification. There's it gets into introduction, which talks about the XML namespace declarations, the abstract interfaces, which talks about the type declarations, interface declaration, message declarations, and finally concrete implementation, which gets into binding declarations and endpoint declarations. So what about the WSDL specification components? The quote, what part of the WSDL document called an interface specifies is what operation the service supports and defines the format of the messages that are sent and received by the service. The how part of the WSDL document called a binding maps the abstract interface to a concrete set of protocols. The binding specification, so the binding specifies the technical details of how to communicate with a web service. The where part of WSDL document describes the location of a specific web service implementation, i.e. its endpoint. So I won't go over this in detail, but here is a part of the WSDL description for a web service and how it would look. A little bit more there. And so let's just briefly talk about this RESTful services. This is RESTful web services. Current web services standards have been criticized as being heavyweight standards that are overgeneral and inefficient. The RESTful, which stands for Representation State Transfer, is an architectural style based on transferring representations of resources from a server to a client. The style underlies the web as a whole and is simpler than SOAP or WSDL for implementing web services. RESTful services involve a lower overhead that is so-called big web services and are useful for many organizations implementing service-based systems. For resources, the fundamental elements in a RESTful architecture is a resource. Essentially, a resource is simply a data element such as a catalog, a medical record, or a document such as this book chapter. In general, resources may have multiple representations. That is, they can exist in different formats, whether it be something like Microsoft Word, a PDF document, or Quark Express. In terms of resource operations, you can have create, read, update, and delete. So you can bring the resources into existence, you can return a representation of the source, you can change the value of the resource, and you can make the resource inaccessible. Here are some examples of how that could look. So you have a general resource actions here, and here is how it would look like if you're trying to do engage with a web resource. What are the operation functionality? You can post, you can get, you can put, and you can delete. Post is used to create a resource. Get is used to read the value of a resource and return that to a requester. Put is used to update the value of a resource, and delete is used to delete the resource. In terms of resource access, when a RESTful approach is used, the data is exposed and accessed using the URL. Therefore, the weather data for each place in the database may be accessed through URLs such as the following. So here, looking at Boston or maybe Edinburgh, you invoke the get operation and return a list of maximum minimum temperatures. To request the temperatures for a specific date, a URL query is used. And then in terms of the query results, so the response to a GET request is a RESTful service may include URLs. In the response to a request is a set of resources, then the URLs of each of these may be included. And so here we're seeing examples of that for Edinburgh and how that might look. What are some of the disadvantages of a RESTful approach? When a service has a complex interface and is not a simple resource, it can be difficult to design a set of RESTful services to represent them. There are no standards for RESTful interface descriptions, so service users must rely on informal documentation to understand the interface. When you use RESTful services, you have to implement your own infrastructure for monitoring and maintaining the quality of service and the service reliability. So here's an illustration of RESTful and SOAP-based APIs. And so just leave that, you can look that over. Let's get into service engineering. Service engineering is the process of developing services for reuse and service-oriented applications. The service has to be designed as a reusable abstraction that can be used in different systems. Generally, useful functionality associated with the abstraction must be designed, and the service must be robust and reliable. The service must be documented so it can be discovered and understood by potential users. Here is an illustration of the service engineering process. And so you have the service candidate identification, you have the service design, and then you have the service implementation and deployment. And each of these has outputs, and you have the service requirements, you have the service interface specification, and finally you have the validated and deployed service. What are the stages of service engineering? The service, you have first the service candidate identification. This is where you identify possible services that might be implemented and define the service requirements. You have the service design. This is where you design the logical service interface and its implementation services, whether it be SOAP or say RESTful. And then you have the service implementation and the deployment, where you implement and test the service and make it available for use. For service candidate identification, the service should support business processes. Service candidate identification involves understanding your organization's business processes to decide which reusable services could support these processes. Three fundamental types of services are there. There's the utility services that implement the general functionality used by different business processes. There's the business services that are associated with a specific business function, i.e. in a university student registration. And there's coordination services that support composite processes such as ordering. For task and entity-oriented service, task-oriented services are those associated with some activity. Entity-oriented services are like objects. They are associated with a business entity, such as a job application form. And utility or business services may be entry or task-oriented. Coordination services are always task-oriented. And here is just a table showing service classifications. And so you have task and entry. And I'll just, you can look this over at your leisure. For service identification, here's some things that you can be asking. Is a service associated with a single logical entity used in different business processes? Is this task one that is carried out by different people in the organization? Can this fit with a RESTful model? Is a service independent? Does a service have to maintain state, or is a database requirement? Could the service be used by clients outside the organization? And finally, are different users of the service likely to have different non-functional requirements? In terms of a service identification example, you can think of a large company which sells computer equipment, has arranged special prices for approved configuration for some customers. And maybe if you've gone to some computer vendors and tried to order something, you would find this, whether it be, say, like HP or Dell. To facilitate automated ordering, the company wishes to produce a catalog services that will allow customers to select the equipment that they need. Unlike a consumer catalog, orders are not placed directly through a catalog interface. Instead, goods are ordered through the web-based procurement system of each company that accesses a catalog as a web service. Most companies have their own budgeting and approval processes for ordering, and their own ordering process must be followed when an order is placed. Okay, what about catalog services? So this is created by a supplier to show which good can be ordered from them by other companies. So in terms of the service requirements, you have the specific version of the catalog should be created for each client. Catalog should be downloadable. The specification of prices of each to up to 6 items may be prepared. browsing and search facilities shall be provided, and a function shall be provided that allows a delivery date for ordering them to be predicted. The virtual order shall be supported, which reserves the goods for 48 hours to allow a company order to be placed. And so maybe if you've done some ordering with Amazon or Walmart.com, you probably would see these kind of things as you go through the ordering process. What about the catalog in terms of non-functional requirements? You need to consider the access shall be restricted to employees of accredited organizations. The prices and configurations offered to each organization shall be confidential, and the catalog shall be available, say, for certain hours. The catalog shall be able to process up to a certain number of requests, say 10 requests per second. So here is a summary looking at the functional description of the catalog service operations. And so you have the make the catalog, create a version of the catalog, look up, display all the data, and search the operation that you can have a logical expression and searchable ways of getting access to that information. You can compare up to 6 characteristics. You can check delivery, and you can make virtual order. So those are things that you can do. What about the service interface design? So this involves thinking about the operations associated with the service and the messaging exchange, the number of messages exchanged to complete a service request should normally be minimized, and the service state information may have to be included in messages. For interface design stages, there's a logical interface design, there's a message design, and then there's the interface design. So for the logical interface design, this starts with the service requirements and defines the operation names, parameters, and services. For message design, this is deals with the designs, the structure, and organization of the input and output messages. Notable notions such as UML are more abstract representations than XML, and the logical specification is converted to WSDL description. Finally, the interface design. This is designed as how the request operations is made onto REST operations, that what the resources are required. So here's a couple pages on the catalog interface design. And so you have the make catalog, the lookup, and the search, and the various inputs and outputs and possible exceptions that you might have to be dealing with. You have the compare, check delivery, and make virtual order. You know, the inputs and outputs and exceptions that you want to be able to handle. And so here is an illustration of a UML definition of the input and output messages. So having all this documented is useful. And for the RESTful interfaces, there should be a resource representing a company-specific catalog. This should have a URL of the form base catalog, company name, and should be created using a post operation. Each catalog should have its own URL of the form base catalog, company name, item number, and the get operation is used to retrieve items. And so there's a lookup function is implemented using the URL of the catalog as the get parameter, and search is implemented using get with the company catalog as a URL and the search string as a query parameter. The compare operation can be implemented as a sequence of get operations to retrieve the individual item, followed by a post operation to create the comparison table, and a final get operation to return this to the user. The check delivery and make virtual order operation require an additional resource representing a virtual order. In terms of service implementation and deployment, programming services using a standard programming language or a window workflow languages. Services then have to be tested by creating input messages and checking that the output messages produced are as expected. And finally, deployment involves publicizing the services and installing it on a web server. Current servers provide support for service installation. For legacy system services, services can be implemented by implementing a service interface to existing legacy systems. Legacy systems offer extensive functionality, and this can reduce the cost of the service implementation, and external applications can access this functionality through the service interfaces. For service descriptions, information about your business, contact details, etc. This is important for trust reasons. Users of a service have to be confident that it will not behave maliciously. An informal description of the functionality provided by the service. This helps potential user to decide if the service is what they want. A description of how to use the services. This gets in, you can have a SOAP-based and RESTful. And finally, subscription information that allows the users to register for information about updates to the service. Okay, what about service composition? For software development within service, existing services are composed and configured to create new composite services and application. The basis for service composition is often a workflow. Workflows are logical sequences of activities that together model a coherent business process. And for example, they provide a travel reservation services, which allows flight, car hire, and hotel bookings to be coordinated. So here is an example of, say, how a vacation packaging flow would work. So the anchor is the flights, then you look at the hotel, the car or taxi, any attractions, and then the ability to book those, and you would complete that vacation package workflow. Here's a figure showing the service construct by composition. And so you formulated an outline workflow, you discover the services, select the services, refine the workflow, create the workflow program, and then have a test service. And so this is the outcomes that would be associated with each one of those steps. For construction by composition, so we'll just go through that chart in a little bit more detail here. So formulate the outline workflow. Initial state of the service design, you use the requirements for the composite service as a basis for creating an ideal service design. For discover services, in this stage, you search service registries or catalogs to discover what services exist, who provides these services, and the details of the service provision. For selecting possible service, your selection criteria will include the functionality of the service offered. They may also include the cost, the quality of the service, and factors like that. For refining the workflow, this involves adding details to the abstract description and perhaps adding or removing workflow activities. For creating the workflow program, in this stage, the abstract workflow design is transferred to an executable program and the services interface is defined. You can use a conventional programming language such as Java or a workflow language such as WSBPEL. And then finally, you want to do the test to complete service or application. The process of testing the completed composite services is more complex than component testing in situations where external services are used. For workflow design and implementation, WSBPEL is an XML standard for workflow specification. However, the descriptions are long and can be unreadable. Graphical workflow notations such as WPMN are more readable, and WSBPEL can be generated from them. In inter-organizational systems, separate workflows are created for each organization and linked through message exchange. Workflows can be used with both SOAP-based and RESTful services. So here's a fragment of the hotel booking workflow. And I won't go through this in detail, but these are the kind of things that you would want to be codifying in detail as you come up with a specific design. So you have, this shows a lot of the customer engagement. And here you have the interacting workflow, the setup of computation, and then the vector processing services. And so that would be some more details. In terms of testing service composition, testing is intended to find defects and demonstrate that a system meets its functional and non-functional requirements. Service testing is difficult as external services are, quote, black boxes. Testing techniques that rely on the program source code cannot be used. And then for testing service problems, external services may be modified by the service provider, thus invalidating tests which have been completed. Dynamic binding means that the service used in an application may vary. The application tests are not therefore reliable. The non-functional behavior of the service is unpredictable because it depends on the load. If services have to be paid for as used, testing a service may be expensive. And it may be difficult to invoke compensating actions in external services, that these may rely on the failure of other services which cannot be simulated. Okay, just to finish up, service-oriented architecture is an approach to software engineering where reusable, standardized services are the basic building block for application systems. Services may be implemented within a service-oriented architecture using a set of XML-based web service standards. These include standards for service communication, interface definition, and service enactment and workflows. Alternatively, a RESTful architecture may be used, which is based on resources and standard operations on these resources. A RESTful approach uses the HTTP and HTTPS protocols for service communications and map operations on the standard HTTP verbs post, get, put, and delete. The utility service provide general purpose functionality. Business services implement part of a business process, and coordination service coordinate execution services. Service engineering involves identifying candidate services for implementation, defining services interfaces, and implementing, testing, and deploying services. The development of software using services involves composing and configuring services to create new composite services and systems. Graphical workflow languages such as BPMN may be used to describe a business process and the services used in that process. Okay, well, thank you very much. We'll just finish up the lecture there.